In today's video, we are going to learn to solve quadratic equations. There are 4 methods for solving quadratic equations. We already know how to factor. We saw that in our unit with rational equations and rational functions where we were finding the zeros of the denominator. We will also review the square root property. Completing the square. And the quadratic formula. First, we'll review factoring. X squared minus x equals 6. When factoring, you first set your equation equal to 0. So we will subtract 6 from both sides. Now we look for factors of -6 that sum to -1. Those will be 3 and 2, where 3 is negative and 2 is positive. Now we use the zero product property, set each factor equal to 0, and solve. X equals 3. Or x equals -2. For x squared minus 14x plus 10 equals 0. The first thing we recognize is that there is a GCF in all of our terms. The GCF is 2. So we start by factoring that out. Parentheses 2x squared minus 7x plus 5 equals 0. Next, we factor the quadratic that's inside the parentheses. Since the lead coefficient is different than 1, we're going to use the AC method. So we need factors of 5 times 2, which is 10, that sum to -7. -5 and -2. Back to our original problem, the 2 stays out front, and I'm going to use brackets to separate the quadratic that I'm factoring from the 2. I'm going to rewrite my quadratic, 2x squared minus 2x minus 5x plus 5. I took the -7x and I split it up using the 2 factors we found over here. Now we factor by grouping. The 2 is still hanging out in the front. We can factor a 2x from 2x squared minus 2x, and we're left with x minus 1. From -5x plus 5, we can factor out a -5, and we're left with x minus 1. Still working within those brackets, we see that there is a common factor of x minus 1. And our other factor is 2x minus 5. This was all equal to 0, and now that it's factored, we set each factor equal to 0. The first equation, 2 equals 0, there is no solution because 2 is never going to equal 0. In the second equation, we get x equals 1. And from the third equation, we get x equals 5/2. Now solve the equation using the square root property. X squared equals 45. Because my x squared is already isolated, we start by taking the square root of both sides. The rule to remember is that when you add the square root, you must also add plus or minus. X equals plus or minus the square root of 45. We must always simplify our radicals. We can factor 45 as 9 times 5, where 9 is a perfect square. X equals plus or minus 3 square root of 5. This yields two solutions. We can separate them with a comma. 3 square root of 5 and negative 3 square root of 5. That's your plus and minus. If you want to leave it in the notation using plus or minus, that's fine with me. X plus 2 squared equals 18. Here we still have something squared. Look at when I cancel that out or I cross that out, we still see we've got a quantity squared equals a number. When we have that quantity squared, to undo that, we take the square root of both sides. And when we take the square root, we have to add plus or minus. Now I'm going to erase what I scratched out. When I take the square root of something squared, we're left with what was underneath the radical, x plus 2. And that equals plus or minus the square root of 18. To isolate x, we subtract 2 from both sides. X equals negative 2 plus or minus the square root of 18. For our final answer, we need to simplify the radical. 18 is 9 times 2. X equals negative 2 plus or minus 3 square root of 2. You can separate your answers using a comma. Negative 2 plus 3 square root of 2. Negative 2 minus 3 square root of 2. I'm reviewing the fact that we can separate those answers. Depending on how your homework is set up, you might need to write your answers separately using a comma. However, for an exam, if you wish to leave it with plus or minus, again, I'm okay with that. Solve by completing the square. X squared minus 8x minus 1 equals 0. First step, we move the constant to the other side. Next, I'm going to fill in this blank space with the quantity b over 2 squared. B is given by negative 8. Negative 8 divided by 2 is negative 4, and negative 4 squared is positive 16. So now I have a plus 16 where that 1 used to be. The golden rule for solving an equation, what you do to one side, you must also do to the other. So I will also add 16 to the right. Now I will factor the quadratic that I have on the left. Factors of positive 16 that sum to negative 8, negative 4, negative 4. 1 plus 16 is 17. And we can rewrite the left-hand side as x minus 4 squared equals 17. Now looking at our equation the way it is now, it looks just like our previous example, and we can use the square root property now to solve. We take the square root of both sides. When I take the square root, I must add plus or minus. X minus 4 equals plus or minus the square root of 17. add 4 to both sides. X equals 4 plus or minus the square root of 17. 5x squared minus 10x plus 2 equals 0. We start this equation the same way by moving the constant to the other side, but we notice the difference between this problem and the last is the lead coefficient. In our next step, we must factor out the lead coefficient from the left-hand side. Notice I did not factor out the GCF from 5x squared minus 10x. I only factored out the lead coefficient because I still want x squared inside the parentheses. We're going to fill in this with the quantity b over 2 squared, but now our b has changed because we're only looking at the quadratic inside the parentheses. The b is now going to be the negative 2. Negative 2 divided by 2 is negative 1. Negative 1 squared is positive 1. Now let's talk about that golden rule. What we do to one side, we have to do to the other side. I've got this plus 1 here, but I also have this 5 out front. It might behoove us to get rid of that 5 right now. 5 is being multiplied by everything in the parentheses, so I can divide both sides of my equation by 5, and now it's gone. X squared minus 2x plus 1 equals negative 2 over 5. And now we can factor the quadratic on the left. This is going to factor to x minus 1 times x minus 1. I made a mistake, guys. We're going to back up just a few steps. Well, actually, a lot of steps. Here, now, again, we've moved the constant to the other side. I apologize for that, guys. I forgot to do something, and it's important that we discuss it. We're going to factor out the 5. X squared minus 2x equals negative 2. So far our steps haven't really changed, but at this step we're going to go ahead and divide by the 5. So we have x squared minus 2x equals negative 2 over 5. So I'm just backing up that one step of dividing by 5. It's going to make things a little bit more clear when we add our b over 2 squared. We fill in this with the quantity b over 2 squared, which is still going to be positive 1. Negative 2 divided by 2 is negative 1. Negative 1 squared is positive 1. Since I added 1 to the left, I also add 1 to the right. This factors to x minus 1 times x minus 1. And now we need to combine the negative 2 over 5 plus 1. I'll do that over here in my margin. We need a common denominator of 5, so I multiply this by 5 over 5. Negative 2 over 5 plus 5 over 5 is equal to 3 over 5. So we have the equation now, x minus 1 squared equals 3 over 5. I'm going to erase all this so that I have some more space, but rewriting what we just had, x minus 1 squared equals 3 over 5. Now I'm at the step where I take the square root of both sides. And I will always remember to add plus or minus whenever I add the square root when solving. We add 1 to both sides. X equals 1 plus or minus the square root of 3 over 5. So we've gotten to our solution. We found out what x is. Now let's talk about the appropriate way of leaving our answer. Here we have the square root of a fraction. If you recall from our previous unit when we learned about radicals, it's not appropriate to leave a fraction underneath a radical. We need to rationalize that. So I'm going to do that in yellow over here. The square root of 3/5, I'm going to rewrite as the square root of 3 over the square root of 5. To rationalize this, I'm going to multiply by the denominator over itself. So this gives me the square root of 3 times 5 is 15 over the square root of 5 times 5 is 25. And now my denominator will simplify. The square root of 15 over 5. This is going to replace that radical. And we can leave our answer like that. Again, I apologize for the confusion, guys. Hopefully you're clear on how to solve that problem. Next, we'll look at the quadratic formula. The quadratic formula, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Anytime you are using the quadratic formula, I encourage you to write it out before you start substituting values into the formula. The more you write the formula out on your paper, the more likely you are to remember it on the test. When you're solving using quadratic formula, just like when you're solving by factoring, you must start with your equation in standard form, which is the same as having it set equal to 0. So we will start by moving the 1 by subtracting it from both sides. It may help some of you to identify what your a, b, and c are. In this equation, a is 2, b is negative 6, c is negative 1. Now we start plugging into the quadratic formula. We start with negative b. Positive b is negative 6, so negative b is positive 6 plus or minus the square root of b squared minus 4 times a times c, all divided by 2a, or 2 times 2. And we start simplifying. Remember your order of operations, you need to simplify inside the parentheses first. Your radical acts as a parentheses, as a set of parentheses. It groups everything underneath it as 1. So that's where we start. Negative 6 squared is positive 36. Negative 4 times 2 times negative 1 is positive 8. Be careful with the sign here. You want to make sure you're paying attention to how many negatives you have so you get the right sign. Over 4. 36 plus 8. The square root of 44 over 4. Now we need to continue simplifying by simplifying that radical. (44) is 4 times 11. So x equals 6 plus or minus 2 square root of 11 over 4. Now that our answer is a rational expression, we need to make sure that it's in simplest form as well. The easiest way to make sure that you simplify this correctly is to start by splitting the fraction. This fraction is the same as 6 over 4 plus or minus 2 square root of 11 over 4. Very often, students will simplify half of this and not the other half. This denominator of 4 is a denominator for both the 6 and 2 square root of 11. So you need to make sure that both of those terms have that denominator. Now that you have split them up, 6 over 4 simplifies to 3 over 2, plus or minus 2 over 4 simplifies to 1/2, or the square root of 11 over 2. You can combine those two fractions as one since they have the same denominator, or you don't have to. One over 6 x squared minus 1/2 x minus 1 equals 0. Our first observation is the fractions, and we don't love fractions. So we want to think about a technique of how can we avoid working with those fractions. And we've seen problems like this. We can clear them by using the LCD. Our LCD is 6, so we're going to multiply both sides of the equation by 6. When I multiply the first, or the left-hand side of the equation, I'm going to distribute it evenly to all three terms. 6 times 1 over 6x squared minus 6 times 1/2 x minus 6 times 1 equals 6 times 0 is 0. Now let's go through and simplify each of our expressions. 6 over 6 is 1, so they go away. 6 divided by 2 is 3. And 6 and multiplied by 1 is 6. So we're left with x squared minus 3x minus 6 equals 0. And now we're dealing with something way more manageable. Our a, b, and c are nice integer coefficients, and using the quadratic formula doesn't seem as daunting. So we had x squared minus 3x minus 6 equals 0. I'm going to go ahead and rewrite my quadratic formula over here so that I'm not just plugging into it, but I'm actually rewriting that formula every single time. Negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Substituting the values from my quadratic, b is negative 3, so negative b is positive 3. So here I've substituted in a, b, and c into my quadratic formula. And now we start to simplify. Negative 3 squared is positive 9. Negative 4 times 1 times negative 6 is positive 24. Nine plus 24 is 33. And we're left with x equals 3 plus or minus the square root of 33 over 2. Again, since we want to try to simplify this as much as possible, you could break this up as 3 over 2 plus or minus the square root of 33 over 2. But nothing is going to simplify even when we do that, so it's not necessary. The square root of 33, hopefully you recognized, will not factor any further. Before we start that next example, let's think about what we've just done. We solved all these equations and we found values of x. In particular, we found 2 values of x. Now, you will solve equations where you have 1 value of x or perhaps 0 solutions to your equation, but I want to talk about what those solutions represent. If we look back at this example, 5x squared minus 10x plus 2 equals 0. What if this was f of x equals 5x squared minus 10x plus 2? What I've done here is substituted in 0 for that f of x, and that's how I got my equation that I solved. F of x is representing our y. What am I solving for when I plug in 0 for y? If you recall, when I plug in 0 for y, that helps me find my x-intercepts. So all these equations that we solved, we were actually finding the x-intercepts for the corresponding functions, which we're going to talk about more when we start graphing quadratic functions. Let's take a look at an application of these quadratic equations. In the next example, we're going to use the compound interest formula. Use the formula a equals p times 1 plus r to the t to find the interest rate if $1,600 is compounded annually, grows to $1,764 in 2 years. To review the variables in this formula, a represents the future amount, p is your principal or the initial amount invested, r is your interest rate, and t is your time. In this problem, they want us to find our interest rate. So if I'm solving for r, they must have given me a value for every other variable. Let's look at what's provided in the problem. $1,600 is representing our principal. If that grows to $1,764, there's your future amount, and the 2 represents the time. So we have 1,764 equals 1,600 times 1 plus r, that's our unknown, squared. We should recognize this 1 plus r squared. That looks like our square root property examples. So to isolate that, we need to divide both sides by 1,600. So we have 1 plus r squared alone on the right-hand side, and we're going to simplify this fraction. This simplifies to 441 over 400. We can take the square root of both sides now, and think about what I kept on saying when we drew the square root. We want to add the plus or minus. So let's continue that, and we'll talk about how that might change because it's an application. 1 plus r equals 441 over 400 is actually a perfect square. This is 21 over 20. And don't forget that plus or minus. Subtract 1 from both sides. So solving this equation just algebraically, we get 2 solutions. We get r equals -1 plus 21 over 20, and r equals -1 minus 21 over 20. But our common sense tells us if we're talking about an interest rate, we can't have multiple interest rates. So which one do we use? Go ahead and simplify these using your calculator to a decimal. What do you get? -1 plus 21 over 20, we get 0.05. -1 minus 21 over 20, we get -2.05. Which of these values do you think is inappropriate? Probably the negative. 1, we see that our principal is growing, so a negative interest rate doesn't seem to make any sense. Second, when you have an interest rate of 2, or something value, if you have an interest rate greater than 1, that's talking about like a 200% increase, and that's not reasonable either. So we found that our answer is the 0.05. There are a few ways that you can represent this answer. You can say r is equal to 0.05 like we calculated, or you can say r is equal to 5%. Now notice 0.05 and 5 are 2 very different numbers. But the 5 has this added unit measure, and that is a percent. That is okay. You cannot do this. 0.05%. Or just leave it as r equals 5. Both of those are incorrect notations for the solution. Either of these are acceptable. So that's a quick review on different ways of solving quadratic equations. Depending on what the question is asking, you might have an option to choose what method works the best. And I encourage you to practice all of them and really develop for yourself a list of what methods you're going to choose in which order. Personally, I always try to factor first. I think factoring is the easiest way to solve. It's certainly the most direct, fastest way. But sometimes I can't factor. So if I can't factor, what do you do next? I choose the quadratic formula next. The quadratic formula will always work. I'm comfortable with it, and I've been using that formula long enough that I have it memorized. Then I would try to complete the square. Notice I didn't include the square root property in that list. The reason for that is that if a problem should utilize the square root property, your intuition is going to make you do that anyway. It's not even going to be something that you think about or realize that you're processing. You're just going to start by taking the square root of both sides. We'll see you guys next time for graphing quadratic functions.